Hi everyone, welcome to the Microsoft Online Tech Forum. My name is Aaron and I'm a cloud solution architect from Microsoft Hong Kong, specializing in the data and AI solution area. This session is about Developers Guide to AI, a data story, which I will share how developers can make use of the services and tools available on Azure for their AI projects. I'll first give you all a high-level overview of the whole Azure AI platform. Then you will be able to learn more about the Azure Machine Learning service, followed by a demo scenario where a company is trying to tackle a business problem with data analytics. The Azure AI platform empowers you to easily get started wherever you want, from using simple APIs to graphical UI-based development and to purely code-based development environments. There are three primary areas that we usually see: AI apps and agents, knowledge mining, and machine learning. So if you're a developer and you're trying to add AI into your applications, the easiest way to do it is to start with cognitive services. Cognitive services are a suite of pre-trained AI models built upon our groundbreaking Microsoft research results, and you can easily plug them directly into your applications. They can combine really well with the Microsoft Bot framework as well. The Azure Bot service provides a lot of out-of-the-box templates for your bot development. On the knowledge mining side, Azure Cognitive Search is a cloud-based search service with built-in AI capabilities to allow you to uncover insights from all of your documents, images, media, and so on. As a developer, you can leverage Azure Cognitive Search to provide a great search experience into your web and mobile applications without having to be a search engine expert yourself. And finally, on the machine learning area, we offer a full stack of services to cover the end-to-end machine learning lifecycle. You can easily and quickly build, train, deploy your machine learning models using the Azure Machine Learning Service, Azure Databricks, and with other AI infrastructure offerings, such as a data science virtual machine as well. So we are also committed to provide an open platform where you can use tools and frameworks of your choice, such as some popular open source frameworks like PyTorch, TensorFlow, and etc. So now let us take a deeper look into the cognitive services. Azure Cognitive Services is a group of services divided into different categories to provide generalized prediction capabilities. The benefit of using cognitive services is that it does not require you to have any previous experience in machine learning. All it takes is just a simple REST API call to embed the ability to see, to hear, to speak, to search, to understand, and to accelerate decision-making into your apps. They are flexible to work on whatever language, framework, or platform that you may prefer. So as of today, we offer 25 plus different APIs designed for different kinds of scenarios. The decision category is one of the latest capabilities that we introduced last year. Specifically, the anomaly detector service enables you to detect unusual data points in your time series data with machine learning. It can adapt and adjust the boundaries by automatically identifying and applying the best fitting models using your provided time series data. Another interesting one is the personalizer. So the personalizer service can help you to help your applications to choose the best content to show to each user. At the back end, it uses reinforcement learning to select the best item or action based on the collective behavior and reward scores across all users. So some of the cognitive services also allow you to provide your own data to easily train up your own models. For example, the custom vision service enables you to upload and tag your own images so that you can have a customized image classifier when you need something more tailored to your scenario. Similarly, we also have custom speech, custom voice, custom search, and others under different categories. I will highly encourage you all to go to our cognitive services website to learn more and to try them for free. We are also helping developers to take these AI capabilities from the cloud to the edge, so that you can also take these cognitive services and deploy them in containers, which you can run on-prem, you can run it on edge device, or you can also run it wherever you want. As these are the exact same AI models being wrapped up in a standard Docker container, that you can download and deploy. This would be really helpful when you have a high throughput or low latency requirement, probably an unstable network connection, or maybe your data is just too sensitive to send to the cloud. So for more information and details, you may visit this link on the screen. And to get started with the developer samples. Yeah. So now we are going to the next step of how do we go from these cognitive services to build something more custom. So you may ask, why do we need to do that? We talked a lot about the cognitive services in the past few minutes and how amazing they are and how they can enable you to get started quickly by just an API call. But however, in reality, there tends to be a 80-20 rule where the pre-built AI services may only fulfill like 70 to 80% of your business needs. So the remaining 20% would require you to build something more custom. This is where you can use the Azure Machine Learning Service. Azure Machine Learning Service is the set of cloud services with the Python and R SDKs that enable you to prepare data, train models, build models, manage them, as well as to track the whole experiments that you are using to build these models. And finally, of course, to deploy the models at scale. So we designed this Azure ML service to simplify machine learning to people with all skill levels. So you can use this designer canvas to help you to prepare data, train, test, deploy, manage, and track machine learning models without writing any code. So there is no programming required. So you simply need to drag and drop different modules and visually connect them together to construct your ML models. Similarly, the automated ML provides a UI for you to upload your data, select which type of ML model you would like to use, and to specify the target metrics. And this service can automatically iterate through different ML algorithms and to tune the hyperparameters for you to generate the best model. So this automated ML capability is based on the breakthrough research from our Microsoft Research Division. And you can also use it with our SDK as well if you prefer to write code. Of course, you can also quickly spin up a compute instance that have pre-installed and up-to-date ML packages, deep learning frameworks, GPU drivers, and etc., and all being managed by the Azure Machine Learning Service. So let us try to understand more about the high-level concepts within Azure ML. A workspace is essentially the top-level resource for Azure Machine Learning. So it provides a centralized place for you to work with all the different other components that you may create when you do your machine learning experiments. So the first one would be models. Models are something that we build, right? So experiments are the training runs and development steps that you use to build your models. So pipelines are reusable workflows that you can use it to retrain your model in the future. So for example, you can have a pipeline that defines all the steps, and then you can, using this pipeline, you can trigger it all over again and again in the future to reiterate, to retrain your model, for example. So a compute target is something that to let you specify which compute resource you would like to use. To let's say when you need to train your scripts or to host your deployment, of course, you need to specify a compute resource where you want to do it. So it can be your local machine, or it can also be a cloud-based compute resource, such as Azure VMs, Azure Databricks, Azure EXG Insight, and etc. So images help us to manage different environments for our model deployments. So deployments is something that it can create endpoints based on your images. So you deploy your images, and that can be either hosted in the cloud or on the edge devices. So finally, data stores are a storage abstraction over the backend storage for the Azure ML service. So Azure Machine Learning Service is designed to help you to manage the end-to-end lifecycle of your ML solutions. So you may have heard of the term before, machine learning operations or ML ops, where we apply the DevOps approach to the machine learning process to achieve faster experimentation and development of models, faster deployment of models into production, and all with quality assurance in place. For example, the first thing that we have to do is to prepare a data set, and this is where we will make use of the data store component. And then we have to choose our experiment environment, and that is where we need the compute resources. And for example, that can be a compute target with pre-installed Jupyter Notebook environment so that you can use it for the model building and training. So probably we have to build and train this model, iterate a few times to have come up with different versions. So once we do have a target that is ready to deploy, then we will register this model and to build an image and to deploy this model into production. So this whole process can actually be stitched together by an Azure ML pipeline so that you can create reproducible workflows easily and to do it again and again in the future. So for the upcoming demo scenario, we'll go through a business problem and we'll try to solve it using the Azure ML service, and to do that from end to end using a process. First of all, let me introduce this fictitious company called Tailwind Traders. It is a retail company that sells DIY stuff, so that such as things that you may need in your home or in the garden and etc. So they have already built a really nice website and mobile application for their customers and partners. And of course, sometimes there may be errors and something that the users don't understand, so they may need to ask some questions. So on this kind of, let's say this is mobile applications, so there's users. So these questions are submitted in the form of some support tickets. So if you know that support tickets, they will come into a system. So they will have a fantastic support team to handle this kind of support requests. But however, there's the problem. So when there are more and more support tickets that are coming in, this support team is starting to feel a little bit overwhelmed, and they are not sure which one they should prioritize. So according to the support team's feedback, so the majority of the customers are actually quite happy when the case is resolved. But unfortunately, some of the customers are not having a great experience, either because they are waiting too long or there is some bug or feature issues within their application. So here's the question. So this is on top of mind for the Tailwind Traders management team, as they would like to improve the customer experience by providing help to the support team. But the real question is, how? Do we want more support engineers to hire more people into this team? Or do we want to stop people from submitting tickets? So what is the next best course of action? So this can be a very broad question, and that's the question that the analytics team is assigned to tackle. So imagine we are the analytics team. So the data analytics team is trying to approach this problem using a data science approach. So first of all, they will look at some of the data that comes into the support system, exploring that data set and deciding what's in it to help us understand more about how we can better help the support team. And then they're going to have to work really closely with the support team, of course, because the support team is really the one who knows the problem the best. So the teams then need to go in and to do some kind of experimentation where we will start to look at predictions, such as forecasting the amount of tickets or maybe the duration of how long the ticket may need to take to resolve. Then we'll look at the deployment so that we can feed back the insights into the support ticket system after we have developed some kind of predictions or models. So last but not least, it is also very important to present the results back to the management team in a different way so that they can understand how we are actually, this team, data analytics team, is actually helping to support the support team. So now let us switch to the demo. So as you can see, this is the typical Azure portal environment. And so in this case, I have already created my Azure Machine Learning workspace here. And here you can see we actually have this new Machine Learning Studio type of experience. So if you click on this button, this will take you to another portal or another screen where this is a unified environment where the data scientists or data analysts will spend their time in this portal. Okay, so as you can see within this machine learning workspace or the studio, and then there are different types of tools that you can actually use to develop your ML models. So for example, if you prefer the code first experience, so you can take a look at the notebooks. So we have already provided some of the samples that you can quickly get started with. For example, some of the tutorials you can reference these kind of notebooks to help you to learn about how to use our SDKs. So if we go back to the screen, and then we can see we have also have the automated ML experience so that we can click on it and to start a new experiment. And this is a click-through wizard that can help you to easily train up a new model using the automated ML capabilities. So the designer interface is the drag and drop feature that we just mentioned about. So for example, here are also a lot of different samples and templates to help you get started quickly. So let's say if we take a look at this sample for the regression type of problem to predict let's say the car price. So here you can see I can easily just drag and drop my data sets out of it, and then I can connect it with other modules. So let's say the first step is to have the data set, and then I would need to select some of the columns and to clean some of the missing data. So for example, I would like to remove the entire row or just replace with some median or mean values. And then it's common for us to split the data so that, for example, into 70% for the training data set and 30% for the testing data set, for example. So you can also do the settings here. So now this is where the interesting thing is about, and you can see that we have already included a lot of pre-built machine learning algorithms for you. So that, for example, in this simple case, I just use linear regression, but maybe you would like to also use the other types and other models. And then you can use this train model to connect this kind of blocks together and then fit into the score model to evaluate the results. So this is really the zero code experience that you just simply need to design your workflow in this canvas. And then after doing all these, you can just simply submit this experiment and it will train according to your instructions. So let us get back to the original scenario, right? So now let's say I'm a data scientist, I prefer to use notebooks to help my experiments. So here you can see we can quickly spin up a compute resource. So let's say I would like to define the machine size, and then I can just quickly do the extra configurations and to get started. So once in few minutes, this will be spin up, and then I can quickly see that. So this already have all the tools pre-built. So let's say I would like to have the Jupyter Notebook environment so that I can click into it, and you can really just get started here. So the first thing, I would like to explore the data to see actually how the Tailwind Trader support team is doing. So for example, from the support systems. So let's say I can see, so okay, I can take some sample data and to see what's actually in it. So there's the support ticket ID, customer ID, which the date creation and completion, whether this is escalated, whether the customer have completed the in-app tutorial, where the customer is located in, and what's the rating, and etc. Okay, so after I have a brief understanding on the data set, so I can also know more about the distributions and like how many data I actually have. So there's around 73,000 records and 19 columns in this data set. So the next step, the common thing we need to do is to perform some kind of feature engineering, right? So For example, we can, so after understanding this kind of data, so we would like to see, so what values would be useful for us to to predict into the future. So for example, we see that there's a binary column, right? Completed tutorial. So basically, some kind of the typical approach is to change this into 0 and 1 so that the algorithms tend to deal with them better. So we've done that for some of the columns. So you see that here in the completed tutorial and the numeric rating. And next, we would like to split the date columns into separate into day, month, and year, so that it's better for us to deal with them in the later stage. Okay, so after this, we will have the new columns being created at the end of the original columns. So next, we would like to also have some kind of quick visualizations to explore the data as well. So let's say we would like to check the pattern. So for the support cases, so actually the peak is around the third quarter of the year, September, October, November. And we see that during the summertime, probably people are on holiday. So that's why they are not really have a high usage and a high support ticket rate. And in the December as well, probably people are on Christmas holiday. Okay, so after this, we can also take a look at some of the durations that we think that this may be helpful as well. So we can see that most of the support cases get resolved in a pretty quick time. And some of them is like having an average of four days to finish. And we can also take a look at whether the tickets are being escalated. So in this case, most of them are not escalated. So probably escalation is not something that is interesting for us to look into. And so let us take a look with this as well. So what kind of theme is with the support tickets. So mainly about support issues, right? So probably about speed as well, about features as well. So these are the top questions or top problems the users may have. So after this, we kind of understand. So probably, so for the IDs, they may not be useful for us to train the data. So we'll just drop them and we will create a new data set to use later for our trainings. So after this, I have already created a new data experiment CSV file. So the next step is to go back to the experiments, right? Let's try. So after we have the data ready, so let's try to experiment with the data. So in this case, I'm going to show you how we can use the automated ML UI experience for a quick test. So let's assume I have already registered my previous data set. So this is the previous data set that I have. You can see you can actually have a sample scripts for you to how to use back this data set within your code. You can also have a quick distribution to show what's actually inside this data set. And you can also see that which model is actually related to this data set. So let's go to automated ML. So we can click on this create new automated ML run to select this data set. So next step, just give it a name and we can choose the target column to predict. So let's say we are interested to know, like to predict how long a support ticket actually may need to take based on this kind of other different columns that we find that is interesting. So duration is our target column. So here we specify which kind of compute instance we would like to use for training. So for example, I've already pre-registered a training compute, but you can also quickly create from here. You can also use like GPU machines as well if you have some quick important tasks or with a huge data set. So after that, you will need to select which task type you are actually trying to use. So for example, whether this is a classification question or a regression problem or a time series forecasting. So in this case, of course, this is a regression problem because we would like to predict the value for the duration. So here you can also have the additional configuration settings. So for example, you may want to, so let's say I would like to use the root mean squared error as the primary metric. So we would like to have this to be as close as 0 as possible, right? To be the best. So you can also choose whether you would not like to ask this automated ML to try these kind of algorithms if you block them. So you can also set whether due to your budget, maybe you don't have so many money to run a lot of compute. So you may also set a limit here, or you would like it to complete as soon as possible. And you can also set the validation type and also the mass concurrency. So after that, you can also see the feature selection here, but I've actually already done it with the Jupyter Notebook in the exploration phase. So I do not really need to choose here. But of course, you can also do it here. You can just simply include or exclude a certain column. So after that, if I click on finish, this will actually go and kick off a automated ML run where it will try to iterate through and to test different kind of models and to test different kind of hyperparameters to find out the best model. So because this will take a little bit of time, so let me show you a previous example that I've already done. So if you click on the experiments, this actually you can see this is all the relevant runs that I've previously done within my experiments. So if you take a look at the child runs, so these are all actually automatically generated by the AutoML. So they are trying to test different models. So let me click on this run. So within this run, you can see that run 1 actually will return the best model after the whole automated ML process is being done. So you can see, okay, so the best model having the error of around 0.26. You can also see other metrics here. So if you go to model, you can actually see how many models is actually being tested, and you can see how long it takes and what's the different error rates. So this would be the best after they sort out, and this folding ensemble algorithm is actually the best for this kind of problem. Okay, so let me click on this model, and I can take a look at the model details as well. So in the model details, I can quickly go to the visualizations to understand actually what's the performance based on predicted versus the true values. So here are some nice visualizations. You can also click on this explanations to see which features are actually more important relative to other features. So for example, in this case, probably we see that, oh, this rating is actually the most important factor that will affect the duration. So after that, you can simply just click on this deploy model to deploy this model when you think that this is ready to use. So just give it a name. So let's say demo deployment. Okay, so demo deployment, and which you can specify which compute type you would like to use. So you can use Azure Kubernetes service for your production level deployment. But in this case, I will just simply use our Azure Container Instances to quickly deploy this model for testing. So after I click on deploy again, this will take a little bit of time. It will actually help you to package the model into a container and to deploy it on the Azure container instance. So it will return you a scoring URL. So this is the HTTP request endpoint that you can just shoot your sample data into it to do a quick scoring. So now let's take a look at the endpoints, previously deployed endpoint. So let's say I have already deployed this previous model based on the automated ML experience. And this will be the endpoint that you're going to use. So let us go back to the notebook environment. So let's see how we can consume this from the code level. So we just input back the configurations using the Azure ML SDK. So after that, we can take a look at this Azure ML 21 AI ML 21 model that I've just shown you in here in this one. So it will return you the score URI and the Swagger URI so that you can see the definition of how to use this endpoint. So after that, so we understand that, oh, so actually the input data is in this kind of format. So I'll just quickly show you this one. Okay, so let's say we have a new case coming in. So these are the attributes of this new case. So this completed tutorial, it's based in Europe region in France, which date is created, whether it is escalated, and etc. So we can simply just pass this kind of data back to the scoring URI and to try to predict the result. So after we submit this into our deployed model, so we can see that the predicted result is around 2.71. So this new support ticket will actually take around 2.7 days to complete. So we can see that if we call this a real-time endpoint, so this you can integrate this API into your support ticket systems so that it is actually can perform some kind of real-time predictions and will be able to understand more about how long each support ticket will actually take, and maybe probably from the management standpoint, they can assign more people or more engineers to help, or maybe more resources as well. Yep. But of course, for the management, they won't really go in to see these kind of HTTP requests. So they're like, what are we doing here after all these data science iterations, experimentations? So what's actually the results? So for this case, I'll use the data visualization tool to help to visualize the data after all these analysis. So I'll use my favorite Power BI for this purpose. So let's say we have already we have exported this kind of data and to plot it in Power BI. So for example, this will be a really great way for people to interact and to play around with the data. So for example, for the management, they may want to understand, oh, for the escalated cases, what are the average duration and what's the distribution like? And for example, they may also want to drill down into a specific month. So for example, for July, okay, so when we drill down, we can see the distribution on by dates, and then we can also see the average duration and the duration of the support tickets. Okay, so after I have done all this, and I would also like to show you, we actually have some kind of AI visuals within the Power BI tool itself. So for the business analysts, they may want to do this kind of simple analysis and simple AI and tasks themselves, so they can leverage the AI visuals here. So for the key influences, it can actually help you to run different models as well. So you may also want to analyze the duration by different kind of other columns. So we can see that when the rating is low, so the average duration will increase. So it can also help you to find out the top segments as well with some explanations. So after all these report is being done, you can quickly publish it into your Power BI workspaces, Power BI Cloud, so that other users can actually simply go to the Power BI portal to see all these kind of shared reports. To conclude, first we looked at Azure Cognitive Services, which is a group of services divided into different categories to provide generalized prediction capabilities. For a more customized scenario, Azure Machine Learning is a cloud-based environment where you can use to train, deploy, automate, manage, and track ML models. Azure ML helps to simplify machine learning for all developers of all skills, and you can have either the zero code, low code experience, such as the designer and automated ML, or to write your own Python or R code with the Azure ML SDKs. This is also an open platform where you can use whatever open source tools and frameworks of your choice. For those who are interested to learn more, I would highly encourage you to visit Microsoft Learn and to check out our documentations for step-by-step tutorials. If you have any questions, comments, or feedbacks, feel free to let us know, and thank you all for your time.